Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about an example related to finding the conditional density of x given y, and this is clearly the case of continuous random variables. Okay, having the continuous random variables. Now, as you have seen in the previous video, the general formula to find the conditional density is going to look like this. If you want to find the conditional density of x given y, the formula is going to incorporate the information that we already know about y, because y has already happened. So here we have like the marginal distribution for y. And then at the top part here, we're going to have the combination of x and y together. So this is the joint density. Okay, so now in this example, what we are looking at is we are going to find the conditional density of x given y is equal to small y, and we're going to use it to evaluate this probability given here. Alright, so there are two questions in this example, and we're going to start off with finding this part first. Okay, well, here we have the whole statement here can be mathematically translated as such. We are going to find what's the conditional density for x given y is equal to y. Okay, and we know that this one is related to find what is fxy, and then we're going to supply the marginal density when y is equal to this value right here. So we're just going to supply the marginal density for hy. Okay, right. Now, what is fxy? So fxy, according to example 3.16, now let us recall example 3.16. This is fxy. Okay, this is the joint probability density for x and y, and we have done in the previous video the result for marginal density of y and the marginal density for x. So these results have you all have seen in example 3.16, and we're just using the results here to continue with this example right here. Okay, right, now what is this one? So this one here clearly refers to this part, which is the joint density, and so just going to plug in that expression here. It's equal to 2 over 3 x plus 2y, and it's between we're considering this two limits between 0 to 1, because now we're focusing on conditional density for x right here. And then at the bottom part here is the marginal density. So marginal density is this one right here. So just going to plug in this expression. So we have 1 over 3 for y plus 1. Now clearly this can be cancelled out, and so what we have is 2x plus 4y over 4y plus 1. So that is the simplified version, if you like, and this one here only applicable for x between 0 and 1, because now we are looking at the conditional density of x, and x can only take these limits right here. And you can write down the answer in terms looking like this, where you can write down the value of 0 elsewhere. Okay, so this value that you got right here is for x between 0 and 1 only. Okay, now that's the first part done, and we're going to use it to evaluate this probability. We're going to find what's the probability of x being less than or equal to half given y is equal to half. Okay, right, I'm just going to erase this part because we already have obtained the answer given right there at the bottom. Now to find the probability in terms of, when you're dealing with continuous random variable, you know that finding the probability will involve integration. So what we're going to do is we're going to integrate. Okay, so we have x less than 1 over 2 given y is equal to 1 over 2. In order to find this probability, we need to resort to integration, and we are going to integrate this one, x given y. So we're going to integrate this function, and this function is because you're talking about conditional probability, therefore you need to integrate the conditional density. So it makes sense to integrate the conditional density of x given y, and we're going to do it with respect to x because right now x is the one that you're interested to find. You're interested to find the probability of x being less than or equal to half. So here we'll tell you what's the limit that you need to plug in right there, and therefore we know that this function given here is for x between 0 and 1, and what we're looking for is x less than or equal to half. So this one will be the upper limit. So 1 over 2, this is 0. Okay, now I'm just going to write down the function, the conditional density given right here. So that is 2x plus 4y over 1 plus 4y dx. And then, sorry, let me just be more specific here. This is actually when, specifically when y is equal to half. Okay, so therefore, this part right here, we can just substitute y equals to half. Okay, that's what I'm going to do. I'm going to substitute this part with the value of half, and this part also with the value of half. Okay, so that makes things a bit simplified for us. Okay, so here we have 2x plus 2 over this one here. The result is going to be equal to 3 and dx. So next we can see that 1 over 3 can be taken outside. So 1 over 3, and we are left with 2x plus 2. And we're just going to integrate that. So the result is 2x squared over 2 plus 2x. And the limits are 1 over 2 and 0. This can be cancelled out. Okay. Next, we're just going to apply or substitute the limits. So 1 over 2 with this one, you will get 1 over 4. 1 over 2 with 2, you will get 1. You substitute 0 into this, you will get 0. So we really don't have to do anything much. So 1 over 4 plus 1, you will get 5 over 4, right? So 5 over 4 times 1 over 3 is 5 over 12. So the answer is given as such, which is 5 over 12. Okay, I think that's all for now. Thank you very much for watching.